We're going to look at graphing and writing equations of ellipses. Now, ellipses are kind of tricky in that they have a lot of information related to them. There's a lot of different things you need to find. So one of the things we need to look at for our ellipses is the center. In this case, it's a nice little center. Remember, the center of an ellipse can be found using H and K. Now, we also have some vertices of our ellipse. The vertices are the endpoints of the major axis. So they're going to be at the ends of the longest part of the ellipse. So when we find these vertices, what we're doing is we're looking for the number that's bigger, A or B, and whatever that number is helps us find the vertex. So we're looking for the biggest. Our cove vertices are on the shorter axis. So these are for the smaller number, whichever is smaller, A or B. And our foci, that's another thing we need to find. Our foci are inside the ellipse, and they help define how curved it is, or how circular or uncircular it is. When we find our foci, we need to find C. And C can be used using the formula C squared equals A squared minus B squared, or B squared minus A squared, whichever one is bigger. You always want to end up with a positive number. It looks like the last thing we're going to look at is the eccentricity. The eccentricity is found by doing C over A. So C, remember, is going to be this distance right here. And A is going to be the major part, the longer part. So our fraction is always going to be between 0 and 1 because we're going to have a smaller number, this C, which would be smaller, over a bigger number. When we have all of this information, we can use it to find even more stuff about their ellipse, and we'll look at that with some specific examples. So here we have the equation of an ellipse, x squared over 64 plus y squared over 25. As we find more information about this ellipse, I'm going to start a graph for this ellipse so we can kind of see what's going on. First off, I'm looking at my numbers and I see that 64 is bigger. That means this is a horizontal ellipse. The widest part, the major axis, is going to be horizontal. I also can see what my center is because I don't have anything. H and K is just 0. So we have a center of 0, 0. Now that I know this, I'm going to graph it. So I'm ready to go. Now our vertices come from the bigger number, and 64 was the bigger number. So we need to take the square root of 64. We're going to get 8. That means our vertices are 8 out from both sides of the center. So in this case, we're going to be at 8, 0, and we're going to be at negative 8, 0. So those are my two vertices. You can write them both out, or you can write plus or minus 8, 0. Now our co-vertices are going to come from the other number, the b squared. So 25. Square root of 25 is going to get me 5. Which tells me that my co-vertices are going to be up or down 5 because it's with y, so I'm going to move in the y direction. That means my co-vertices are going to be at 0 plus or minus 5. There we go. It's both of those 2 points. So I actually have enough information to sketch my curve now, but we still need to find the foci. Those are very important when it comes to using ellipses in applications, and so we need to be able to find them and locate them on the graph. Remember, the foci come from using C. So C squared equals A squared minus B squared. So in this case, C squared is going to be 64 minus 25. So C squared is going to be 39. Which means C equals the square root of 39. And thankfully that doesn't simplify any further. So that means our foci are the square root of 39 out from the center in the x direction because they're on the major axis. So they are going to be in between those 8 and -8 points, the vertices that we had. So in this case, our foci are going to have an x-coordinate of plus or minus 39, and we are going to have a y-coordinate of 0 because that's where our ellipse happens to lie. We can answer another couple of questions about this ellipse. We can figure out how long the major axis is. The major axis is from vertex to vertex. So this major axis has a length of 16. The minor axis is from co-vertex to co-vertex. So this particular ellipse has a minor axis that is 10 units long. The eccentricity, remember, is c over a. So that's the square root of 39 over a was 8. Sometimes this value can be simplified, in this case it can't. So, look at all of that information we found from that one little equation. Now let's look at an ellipse that's been shifted around a little bit, and you'll see how that changes what all of the important information is for that ellipse. So this ellipse is an ellipse that's been shifted, and I know that because we can see those values of h and k. So the center for this ellipse is at 3, 1. Now again, I'm going to start sketching a graph now. When you find the information, you might as well put it on your graph right then. It's easier than waiting until the very end. It also helps you visualize where things are at. So now we have our center, and I'm looking at those numbers. And I see that 36 is the bigger number, so this tells me that this is going to be a vertical ellipse. I'm going to be going up and down farther in a larger direction there. So when we find the vertices, we need to take the square root of that, and that number is going to be 6. This tells me that I'm going to move up 6, and I'm going to move down 6, and those are going to be my vertices. So remember, we were at the point 3, 1, and if we move up 6, we'll be at the point 3, 7. If we move down 6, we'll be at the point 3, -5. So you can see why graphing is helpful. You can see what those 2 points are. Now for our co-vertices. Our co-vertices are going to come from that 16. Square root of 16 will get us 4. So this tells me I'm going to travel 4 in the x direction, because that 16 is with the variable x. So starting at the center, we'll travel 4 to the right, and we'll travel 4 to the left. So in this case, when we travel 4 to the right, we were at the point 3, 1. Now we're at the point 7, 1, because we traveled 4 over. Now if we go to the left, starting at the point 3, 1, we would be at the point -1, 1. So now we actually have enough information to start to sketch our curve. I'm really bad at drawing ellipses, don't laugh. And now we need to find our foci though. So our foci come from using that equation, c squared equals a squared minus b squared. So in this case, our foci will be c squared equals 36 minus minus 16, which means c squared equals 20. So c equals the square root of 20, which actually can be simplified. We can pull out the 4. So we can say that c equals 2 times the square root of 5. So now this tells me where my foci are. I'm going to be moving up and down to the square root of 5. I'm going to put those on the graph so you can see what's going on. So we're starting at the point 3, 1, and then we're going to move up 2 times the square root of 5. So when I write my foci, I'm starting at 3, 1, and then I'm going to move up 2 times the square root of 5. I'm going to leave that number separate like that. We can't combine them any further unless we wanted to get a decimal, and that's not very precise. Now for the other focus, we move down to the square root of 5. So you can write them both out, or you can just think, okay, I was at 1 and then I subtracted, so you can use the plus or minus symbol there as well. Alright, we did the hard stuff. Now let's look for our major and minor axes. The major axis, remember, is the length of the longest diameter. So we used 6. We went up 6 and down 6, which means all together we traveled 12 on the major axis. The minor axis is side to side, so we went over 4 to the right and over 4 to the left, so altogether we traveled 8. Our eccentricity. Eccentricity is going to be c over a, so it's going to be 2 times the square root of 5, divided by a in this case was 6, because that's the bigger number. So here I told you sometimes it can be simplified. 2 and 6, yep, they simplify. So we can say our eccentricity is the square root of 5 over 3. I just want to look at one more equation that's been given to us before we move on to writing our own equations. Because the more familiar you are with all of these attributes of ellipses, the easier it will be to write equations. So here we have an ellipse that has a center that's been shifted. And if we look at our equation, we can see the h value, and then for k with the y, it would be 0. So our center is going to be at 2, 0. The other thing we can do just by looking at our equation is we can determine whether it's going to be vertical or horizontal based on the bigger number. What do you think? 25 is bigger, so since 25 is with the y, it's going to be a vertical ellipse. I'm going to go ahead and get my graph ready. I know my center is at 2, 0, so I have that point there. Now for my vertices, I'm going to use that 25, take the square root, and that gets me 5. That tells me that I'm going to travel up and down 5 to get to the vertices. Up and down because it's with the y. So we travel up 5 and down 5. In this case, it's kind of nice because we're starting at 0 and we travel up 5. So we're going to be at 2, 5. And then we travel down 5 and we're up to negative 5. You can use the plus or minus symbols if you want, or you can write them out. Doesn't matter in this case. Cove Vertices. Cove Vertices are going to come from the 9. Square root of 9 is 3, so that's the number we're going to be using. We're going to travel left and right 3. So when we travel to the right 3, we started at 2, 0, and then we end up at 5, 0. When we travel to the left and start at 2, 0, we're going to move to the left 3, so we're going to be at negative 1, 0. So those are our cove vertices. And again, we have enough information to sketch our curve, but we do need to still find the foci since those are really important, like I said, in applications. So, foci. C squared equals A squared minus B squared. So in this case, C squared equals 25 minus 9. C squared equals 16. Hooray! C equals 4. Finally, a nice one, right? This tells me that I'm going to move from the center 4 to find my foci. And since the major stuff is happening with the y, I'm going to travel up and down 4. So we travel up 4, down 4. Now that is going to help me write out those coordinates. I started at 2, 0 and I traveled up 4. So I ended up at the point 2, 4. I started at 2, 0 and I traveled down 4. So then I'm at the point 2, negative 4. Plus or minus you can use if you want, or you can write them both out. Last thing we're going to do is look at those major and minor axes and the eccentricity. So the major one is the long one. How long is that diameter? It's going to be up 5, down 5, 10. Then our minor, how long is that shorter diameter? We went over 3 to the left and over 3 to the right. So that's 6. And our eccentricity is going to be C over A. C is 4, and A was 5, the bigger number, so we can't simplify it. Here you can clearly see 4 over 5 is a fraction that's in between 0 and 1, which is good because the eccentricity of ellipses is between 0 and 1. It's fairly close to 0 because they're circles, but because they're related to circles. However, that difference, that spreading out, that makes the ellipse longer, that's what makes the eccentricity become larger. Alright, we graphed a lot of stuff. Now we're going to write some equations. When we think about the equation of the ellipse, there's a lot of information in it. We have x minus h squared over a squared plus y minus k squared over b squared. That equals 1. So the center, the vertex, the foci, the cove vertices, everything is related to this one equation. Now we have some given information about a particular ellipse. We know its center, we know one of the vertices, and we know one of the foci. Given this information, we want to write the equation. Well, let's go ahead and get started. The center, that's easy, so let's plug that in. We get x plus 4 squared over something plus y minus 7 squared over something equals 1. Now let's try to find those somethings. Those numbers are related to the vertices and the cove vertices. We have a vertex. Let's figure out what we know about this vertex by sketching a graph. You know we have negative 4, 7 as my center, and the vertex is at negative 4, negative 3. The focus is at negative 4, 0. So if we think about what we know about this ellipse, we actually know half of it. We could reflect these points and get the other half. This ellipse is going to be a tall ellipse because that major axis is vertical. So that lets me know where my bigger number is going to go. It's going to have to do with the y. And I can figure out what that bigger number is because I know the distance from the center to a vertex. So let's think about this. We were at negative 4, 7, and we went all the way down to negative 4, negative 3. How far did we go? We traveled 10. So that lets you know what goes with the y. We went up and down 10 to get to a vertex. So underneath the y, we're going to have 10 squared, which is 100. Now, the foci. Let's think about how far we traveled to get to the focus. We traveled from negative 4, 7 to negative 4, 0, so we went down 7 this time. Now that just gives me c, and there's no place for c in my equation. However, remember our equation for c is c squared equals a squared minus b squared. And we actually know a, and we know c, so we can find b squared. So c squared is going to be 49 because 7 squared is 49. And a squared is 100. Subtract and you'll get negative 51 equals negative b squared. So positive b squared equals 51. Now yeah, the square root of 51 is kind of gross, but think about our equation. B squared is what we want. So we can fill that 51 into our equation and we're set to go. We have the equation for the ellipse having the attributes given to us initially. So here's another ellipse. This time we're given the foci and the length of the minor axis. This is one I'm definitely going to draw a picture for so I can figure out what I actually know besides just those 3 pieces of information. So we're sketching the graph. I know the point negative 4, negative 1 is a focus, and I know the point 8, negative 1 is focus, which means this is the major axis. It's going to be horizontal. What do we know about the foci? We know that they're equidistant from the center. So if I wanted to find the center, it's going to be halfway in between. Well, the distance from one focus to the other focus, it looks like negative 4 to 8, that's 12. So halfway in between means going 6. So if we started at negative 4 and we went 6 to the right, we would be at 2. And then it's all along that same negative 1 line, so we just went ahead and found the center. 2, negative 1 is the center. Now that I have that information, I'm going to start my equation. x minus 2 squared over something plus y plus 1 squared over something equals 1. Alright, we have our foci, which means we have the value of c. We have that value, we already found it, it's 6. But c isn't anywhere in the equation. So let's think about that extra piece of information we were given. We were told that the minor axis is 16 across. The minor axis is 16 across. That means that up and down to the cove vertices would be 8 and 8. So we actually know b. b is going to be 8. So b squared is 64. Which variable does that go with? If it goes up and down, it goes with the y. So we have 64. Remember our equation using c is c squared equals a squared minus b squared. We know c and we know b. So it looks like 36 equals a squared minus 64. So add 64 to both sides and we get 100 equals a squared. Do we care what a is? Not in this case. We only need a squared to write our equation. So I'm going to write 100 under the x and we're done. So let's check our equation. If we look at our equation, the bigger number, the major axis, should be horizontal because of the x, and that's true based on my picture. Then looking at the equation, the minor axis should be the vertical one. That's true based on my picture. So we have our numbers in the correct place, and we can state fairly confidently that this is the equation for this particular ellipse. Just wanted to do one more just to look at some other information that we might be given about an ellipse. Plus, I have to admit I kind of like to do them. It's kind of like finding a puzzle. We're finding all the missing pieces. So right now, the pieces that we're given are the cove vertices and the length of the major axis. We want to find all the missing pieces to write the equation. Everybody's rolling their eyes. It's cool. Let's find the missing pieces. I'm going to graph what I know. I know that my cove vertices are at -2, 2, and 2, 2. Now those are the cove vertices, but it doesn't matter that they're cove vertices. We know something that sits right smack dab in the middle of those two things, and that is the center. Well, in this case, it looks like the center, since that's 2 away and that's 2 away, the center is going to be on the y-axis. So the center in this case is going to be 0, 2. Cool. Now let's go ahead and start our equation. X squared, since h is 0, we don't have to worry about adding or subtracting anything, over something, plus y minus 2 squared over something equals 1. If those are the cove vertices, which number do we get from the cove vertices? We get b. So we actually have b right there. It's 2. And look at the direction our minor axis goes. It's horizontal, so it needs to go with the variable associated with the horizontal direction, and that's the x. So underneath x squared, I'm going to write 4, because 2 squared is 4. Now we need to think about that major axis. We were told that the major axis is 6. So I would go up and down. That whole direction would be 6. But for putting the number into our equation, we only need to know half of it. How far do you go from the center to a vertex? Well, if the whole thing is 6, half of it is going to be 3. So that gets us our other number. So 3 squared is 9. We have all the pieces of our puzzle. We're done. The equation for this particular ellipse is x squared over 4 plus y minus 2 squared over 9 equals 1. So that was graphing and writing ellipses. I know that this was really long, but that's because there's so many important pieces of information about an ellipse. I need you to make sure you take some time to practice finding all the different attributes of ellipses. There's a lot of different things to remember, and the more you practice, the faster you'll get at figuring all of these things out, and the easier it will come to you. So, practice, practice, practice.